I want to welcome you on behalf of the USC Dialogue Series, which this year is the Road to the White House 2012. And for those of you who may be new with this today, this is a joint effort of the Dornsife Jesse M. Unruh Institute of Politics, the Annenberg Center on Communications, Leadership, and Policy, and the Judith and John Bedrosian Center on Governance in the Public Enterprise at the Salt Price School of Public Policy. I'm Dan Mazmanian. I'm director of the Bedrosian Center, and I'm delighted to be hosting and moderating this discussion today, and we're very fortunate. It's going to be led off by Professor Detloff von Winterfeld, who's a joint professor at the USC Price School and the Viterbi School of Engineering, and he has just recently returned from a 3-year appointment as a director of the International Institute of Applied Systems Analysis in Vienna, Austria. And this institute does look at these critical issues of nuclear power worldwide. So we're very pleased to have Detloff with us today, and he'll speak for a few moments to introduce the topic to us and thinking about the U.S. and its nuclear policies. We have two students who are going to comment and contribute to the conversation. One is Travis Glenn, who's right in front of between the two here, who's a USC junior majoring in international relations, who has researched and written papers on weapons of mass destruction, U.S. security policy, and nuclear non-proliferation. Should have interesting comments to make also. He's president of the International Relations Undergraduate Association. Christian Patterson is a freshman from Dallas, Texas. Welcome. Majoring in political science. He's also a member of the Annenberg Policy Debate Team and the current events director of the Students for Barack Obama. With that introduction, I'm going to turn over to Detloff. The podium's yours, Detloff.
It's really a great pleasure to be back at USC. I came here originally in, if you believe it or not, 1973. Pretty much stayed here all of my life with the exception of my 3-year stint in Vienna. And aside from the fact that it's really good to be back at my home university, it's also wonderful to be in this weather, because in Vienna right now it's minus 10 degrees Celsius. So this is an extra bonus for my return. I'll talk about the future of nuclear power in the United States. And basically, I will have 4 sections, about 20 slides or so. It's going to be about 20 minutes. The first few slides are a brief summary of nuclear power and the mix of nuclear energy supply in the U.S. and forecast for the next 40 years. This comes from the work with YASA, my institute, my previous institute. The bulk of my talk will be about obstacles to nuclear power, and I will go into some detail in that. Briefly at the end, I'll talk about benefits of nuclear power, and then how does the nuclear power discussion play out right now in the current presidential debate. So let me talk about first the big picture of nuclear power in the United States. See the slide here. This is from 2009. This is the electricity supply mix in the US. Hasn't changed very much since then. Nuclear power produces about 20% of the electricity in the US. Natural gas and coal are the other 2 contributors. Coal is still growing, and you probably heard that nuclear power has a bit of a revival with 2 most recent permits in Georgia. 2 plants having been permitted in Georgia, which may or may not come online in the next 10 years or so. The other contributions are relatively small. Hydroelectric and renewables are growing, especially wind, solar, and geothermal, but they're still a pretty small part of the energy supply mix. Now that was just electricity. Now if you're looking at primary energy, it looks a little bit different. Nuclear power has a much smaller part of primary energy. That's that yellow line here. This is a function of time between 2000 and 2050, so it's a forecast. First 10 years are the past, and then the forecast for the next 40 years. Coal is expected to grow. Oil stays stable. Gas will grow, especially with shale gas. Nuclear power will grow a little bit, and then bioenergy, renewables will grow. This is based on, forecast is based on the assumption of business as usual. No particular constraints on climate change. So you have to keep that in mind when you look at this slide. It pretty much doubles the primary energy demand in the next 40 years, a little bit less than double, and coal will increase. This is not a pretty picture. I mean, I don't think anybody wants this particular development. We don't want energy to grow that fast, and we don't want coal to grow that fast because of climate change constraint. This is the picture that, according to our institute at IASA, we would like to see if climate change constraints are taken seriously in the United States. We have similar pictures for various other parts of the world, and this is just for North America. In this case, if you take climate change seriously, meaning that you would like to keep the average temperature increase in the world to less than 2 degrees Celsius, or another measure is 450 ppm CO2 concentration in the atmosphere, then you have to pretty much phase out coal. You have to reduce your reliance on oil. Gas is relatively benign, so you can maintain that for a while. But you have to increasingly rely on renewables, wind, solar, biomass, and you can't do it without nuclear power. So if you take climate change seriously, as many of us do, nuclear power is likely to grow, will have to grow as a major primary energy source in the next 40 years. However, there are many obstacles, and I'll touch briefly on 4 of them, and those are the key ones. Safety. The picture there is from Fukushima, the hydrogen explosion in one of the plants. There were 3 plants involved out of the 4 that had meltdowns. The nuclear waste issue that many of you know, the nuclear proliferation issue, and then the cost issue. Briefly on safety, there have been many risk analyses of nuclear power plants over the past few years. In the pre-1970s, most of the analyses were worst-case analyses, and they were very scary in the sense that you could have scenarios in which maybe 10,000 people would receive enough nuclear radiation doses to suffer from cancer eventually. In 1975, a seminal safety and risk analysis was published by Norm Rasmussen at MIT called the WASH 1400 report, and you see an icon there on the left of the slides here. These are exceedance probability curves. On the x-axis you have the number of fatalities. On the y-axis you have relative frequency or probability. So for example, here on top you've got a curve that is for dam failures. So you have a 10 to the minus 2 probability of having 1 fatality, and it goes all the way up to 10,000 fatalities with less probability per year. And down here in that report was nuclear power plants, for all 100 nuclear power plants projected in the United States, with 10 to the minus 4 probability for all 100, at 1 fatality and going over 1,000 fatalities with decreasing probability. By and large, these sort of numbers have been considered rather optimistic now. In fact, the statistics don't pan these numbers out, that there are much higher risks than Rasmussen at the time predicted. And in 1990, there was a follow-up study, NUREC 1150, with pictures shown on the right that I was involved in, that showed that the risks were roughly 10 times higher, and that in addition to that, the uncertainties were so large that it was hard to pin down what the exact risks would be. Now, subsequently, of course, we did have major nuclear accidents, and You will know three of them, but some of you may not know the first one, which is the Browns Ferry fire in 1975, which came very close to a nuclear meltdown, but nothing else happened. It was an incident in which a worker checked the electrical system, and to find out whether or not there was an airflow in the building where they had electrical equipment, he lit a candle. That was their test for airflow in the building. And when the candle flickered, they knew that there was something wrong. Well, the candle did flicker, and not only did it flicker, it also set the whole building on fire, which caused a station blackout. The 3 Mile Island was a loss of coolant accident. That's on the upper right. Chernobyl was a major operator failure. And then Fukushima was due to the tsunami and the lack of generators working after the tsunami. So we had 4 major nuclear accidents at least, many minor ones. And if you look at that in perspective, if you compare that to the risk analyses of 75 and 90, the core melt probability, like an accident that leads to melting of the nuclear core, was estimated then at about 10 to the minus 5 per reactor year. An offsite release, namely that radionuclides would be released into the atmosphere, was estimated to be below 10 to the minus 6 per reactor year. The actual experience of nuclear power plants in the world was that we currently have 450 nuclear power plants, 100 of which are in the United States, about 14,000 reactor years, so the number of years that these reactors have operated times the number of reactors, and 3, or you could argue 5 core melts, because Fukushima could be counted as 3 core melts because 3 units had problems, and 2 large offsite releases. If you just use the statistics, these numbers are about 10 to 100 times larger than the risk analyses. So that is really something we need to worry about. The second part that we need to worry about is nuclear waste. Nuclear waste is primarily spent fuel. Spent fuel is taken out of the reactors upon the time when they're not sufficiently strong anymore to produce a chain reaction. They're put into pools, literally pools, in the reactor building. You see that on the left there, to cool off, and then put into dry storage, which you see on the right, which are blocks of spent fuel rods that are surrounded by cement and stored somewhere on the site. So you see some people here standing next to the nuclear waste storage site area, and I was in these areas myself, and there's very little waste that is accessible, and the radiation doses are extremely small when you get there. So that's not the problem. The problem is eventual leakage, terrorist attacks, and things like that. We now have nuclear waste all over the country. This is just a shot of all of the nuclear waste site, including the high-level waste site that come from the production of weapons-grade nuclear materials, like highly enriched uranium and plutonium. And so the nuclear waste and the high-level waste is all over the world. And the idea was to consolidate these nuclear wastes and high-level wastes in a few sites. And again, I was very much involved in 1986 when the Department of Energy selected among 5 sites to find the final site for our nuclear waste in a deep geological repository. And the 5 sites are shown here on the map. And the site that was eventually chosen was Yucca Mountain in Nevada. Here's a shot of Yucca Mountain. On the left, you see the environment. One of the reasons why you choose a site like Yucca Mountain is because of the dryness of the environment, very little rainfall, and so very little possibility of corrosion of nuclear materials. You can also see that Yucca Mountain is close to Las Vegas, so you can imagine what the folks in Las Vegas thought. They all call it a nuclear waste dump next to the casino. Wasn't this such a great idea? And so Yucca Mountain had a lot of initial problems, and as it went on, the problems actually increased. In the late 1990s, I did a study of the cost of Yucca Mountain, which seemed to explode at a very rapid rate. In 1987, when we studied Yucca Mountain as a site, it was estimated that the total life cycle cost of Yucca Mountain for the whole 40 years of operation would be $9 billion. In 2001, it was estimated at $57.5 billion, and just recently in 2000, well, not so recently, but in 2008, it was estimated at 96.2 billion. In comparison, the inflation rate between 1987 and 2008 was would have justified an increase of a factor of 2, and what we're seeing here is an increase of a factor of 10, which is due to all sorts of reasons. Not some of them are technical and some of them are political. And there also were some significant suitability issues. There was an earthquake fault discovered that went through Yucca Mountain, the Ghost Dance Fault. There was a concern with corrosion of casks through water infiltration, and eventually the Environmental Protection Agency was ordered by the Supreme Court to change their standard for Yucca Mountain, which is an environmental standard for radionuclide emissions from the site, from a 10,000-year standard, to a 100,000-year standard, meaning they needed to predict what would happen to the radionuclides over the next 100,000 years, which is mind-boggling if you think about it. 10,000 years, by the way, is roughly civilization as we know it, backwards. So 10,000 years in the future seems a very big step. So Yucca Mountain clearly had problems, and the end game of Yucca Mountain was that President Obama in his election campaign in 2008 promised the Nevadans that he would shut down Yucca Mountain. Now, I don't quite think this was purely a technical reason why he did that. I think surely there was a lot of opposition to Yucca Mountain in Nevada, and I think President Obama got himself a lot of votes by arguing against Yucca Mountain. But that's the state. We don't have currently a nuclear waste repository site. I'll comment on that at the very end. Nuclear proliferation, I'll talk only very briefly. In fact, I'm sort of running out of time, so I'm going to skip about that over there a little bit. There are basically two big risks with nuclear material. One on the right is a nuclear weapon, and that is related to state-sponsored terrorism, as well as terrorists obtaining enough nuclear material to build a bomb and releasing it releasing it in the United States, which would, with devastating consequences. There are estimates of consequences of a suitcase bomb being released in Manhattan, which have untold fatalities and destruction. And on the left, you see a study that we did at a previous center here at USC, the Center for Risk and Economic Analysis of Terrorism Events, that shows that even if you get hold of a relatively minor amount of radioactive material, you can set off a bomb, a regular bomb, and disperse materials that could have wide-ranging effects. Like this is a bomb that was dispersed theoretically at the harbor of Los Angeles, and the cloud goes all the way up to Whittier. Many sources of dirty bomb materials for nuclear weapons, for nuclear materials, medical and research facilities, industrial radiators, and then of course from the nuclear fuel cycle, especially in facilities that use reprocessing, like in Russia. If you have sufficient amounts of nuclear weapons-grade material like highly enriched uranium or plutonium, you wouldn't use it for dirty bomb material. You would want to build a bomb if you're a terrorist, because that is certainly a much more destructive weapon. So the bottom line on dirty bombs is that it isn't a weapon of mass destruction, but a weapon of mass disruption. You don't really kill a lot of people with it, probably no more than hundreds of casualties, cancer, long-term cancer. But you can contaminate large areas, which can cause enormous decontamination cost. We estimate for that cloud that I just showed you $100 billion of contamination, massive economic losses in the same order of magnitude, and losses in property values, because houses, even with a very small amount of residual radiation, will lose property values quite rapidly. Now, nuclear bombs, the picture is much more complicated, and I think there's only so much you can do with nuclear power related to nuclear bombs control. Right now we have states with nuclear power, with nuclear weapons, the United States and Russia. Israel has not acknowledged that it has nuclear weapons, but I think everybody believes it does. China, India, and Pakistan have nuclear weapons. And states close to having nuclear capabilities were South Africa. I don't know how many of you remember that, but with the end of apartheid, a deal was made that the nuclear weapons program would be shut down in South Africa as well. But of course, North Korea, you heard much about, in Iran, you heard increasingly about nuclear weapon states that could potentially use their nuclear weapons for nefarious purposes. Now, part of it is state terrorism, so in a way that we're worried about Iran and North Korea either using nuclear weapons themselves for terrorist-like purposes or giving it to terrorists to have attacks in the United States. For that, they need to give sufficient amounts of plutonium or highly enriched uranium to the terrorists, and once they have that, it's actually scary to hear, but it's quite easy to build a nuclear weapon. There was a professor, an engineering professor at MIT, who asked his students to design a nuclear weapon if they had enough nuclear weapons-grade material. There's a gun-type device which almost everybody in the class figured out within a week. And then there is an implosion-type device which a couple of people actually figured out how to do. So the only conclusion that we have in terms of nuclear materials, other than the big picture deterrence and economic sanctions and political pressures that are being exerted on North Korea and Iran, is to protect the materials where they are being created, especially in the countries that have lots of nuclear weapons. The final aspect of nuclear power plants that raises concerns is its cost. There still is a very high investment cost relative to other plants. Nuclear power plants cost now around $7 billion in investment. There were just recently 2 permits at $14 billion together, so that has been validated in that sense. We've been involved in some studies of large advanced light water reactors that cost in the late 90s, early 2000s between $5 and $8 billion in investment cost. And they also have higher levelized costs than alternatives. So below there you see a graph that shows you in yellow the cost in dollars per kilowatt hour for nuclear plants in yellow, and the other ones are for coal and for gas. So nuclear power still has a disadvantage in investment cost. However, the long-term costs are cheaper. In Germany, for example, prior to Fukushima, there was a plan to extend nuclear power plants for 10 years, and that would have been essentially gravy for the utility industry, because the operating costs are quite cheap compared to coal and gas. And since the investment has already been written off, it would have been extra income to the utilities. Now Germany, by the way, has a new plan to shut down all nuclear power plants by 2020. Now, let me just say as a couple of final slides that there are certainly benefits to nuclear power. I don't want to give a picture that everything is bad about nuclear power. It doesn't have CO2 emissions, so it's climate friendly. It also has no other air pollutants. While it has the waste materials, it has no air pollutants. It does reduce reliance on imports of oil and gas, and there is long-term available fuel, namely highly enriched uranium that we have the capability of enriching. We actually do have lots of excess plutonium from nuclear weapons that we can use also for nuclear power plants. And in the long run, it may be cheaper than oil and gas, primarily because oil and gas get more expensive. But also, if you run nuclear power plants for a long time, they will be quite inexpensive. So how does this all play out in the elections? And I know that you're particularly interested here in the topics related to the election. Obama, on surface, sounded a little bit schizophrenic because he shut down Yucca Mountain, which really put a cramp into the nuclear power development. On the other hand, he's supporting nuclear power through Stephen Chu, the Secretary of Energy, and others, and provides loan guarantees for developers of nuclear power and utilities. It isn't really schizophrenic because I believe that the shutting down of nuclear power of Yucca Mountain really had very little to do with nuclear power. It was just a concession that was being made to get votes in Nevada. Gingrich, turns out I Googled them a little bit. Gingrich is the most vocal supporter of nuclear power. He said that climate change problems in the United States can be solved by expanding nuclear power plants to replace coal. That's probably roughly true. So he goes way out on a limb in that regard. Romney supports nuclear power as part of the U.S. energy mix, and Santorum is quite quiet about it, but implicitly he supports nuclear power. That's probably the reason why you don't hear much about nuclear power in the current debate, because nobody wants to get into that debate at all. They're just arguing, they don't want to wake up a sleeping dog. And I was surprised that they don't argue about it. Most arguments are about proliferation, and nuclear power per se has very little to do with that. So my conclusion is that we probably won't hear much about nuclear power in the current debate, maybe sometimes related to climate change, maybe sometimes related to proliferation. But at the moment, I think there's across-the-board support that nuclear power is needed in the long run in the United States if we want to effectively tackle the climate change problem. With that, I just want to pass it over to my discussants and look forward to the rest of the presentations and discussion. Thanks very much.
I was going to say, I'm sure there'll be a number of questions, but first of all, I think we're going to turn to our two discussants to comment, add thoughts, and responses if you care to. Which one of you would like to begin? Chris, go ahead. Take the mic there.
I think what we've seen so far is that nuclear power and more generally energy production has affected the election in two key ways. I guess the first way is energy prices. What we've seen recently is that Obama has gotten a boost in his approval rating and his chances of getting reelected because of, I guess, a strengthening economy. While it's not growing as fast as we wanted, what we've seen recently is decreasing unemployment, strong manufacturing, and other economic factors that make people see Obama more favorably and make his chances of reelection higher. I guess the reason that energy prices are affected is that what we're seeing is the GOP and Republicans mobilizing the energy prices. In the last couple of months, we've seen an increase in gas prices at the pump, 20 cents, national average of 20 cents since December. And we've seen the GOP kind of trying to mobilize on the issue of the Keystone XL pipeline, which is a pipeline that would go to the Midwest. It would make energy cheaper, it would lower gas prices. And we've seen, I guess, the Republicans try to use energy prices as a way to show that Obama's not really helping the economy in that scenario that we're in. Because the economy is going down, even if slowly, that's an area of strength for him. But if economic confidence were to go down because of higher oil prices, because people see him as an obstruction to lower oil prices, that's the reason that could hurt him in November. The second key way that nuclear power, even if not nuclear power in the U.S., affects the upcoming elections is that we're seeing a split between the United States and Israel over policy regarding Iran's nuclear ambitions. What we're seeing in the status quo is that the IAEA and both the UN have released reports saying that Iran is using nuclear power in order to weaponize it to develop its mass destruction. And we're seeing the U.S. and Israel kind of split on how they're going to deal with that issue. Right now, the GOP is trying to frame the Obama administration as not being strong enough to protect Israel because the Obama administration has defaulted things like sanctions, using the UN, using peaceful means to try to get Iran to stop proliferating and to stop weaponizing its nuclear supply. But we've seen allies like Israel who see Iran as a bigger threat try to, I guess, push the idea of striking Iran, take out nuclear facilities, stronger sanctions, stronger initiatives to try to take out Iran and prevent them from weaponizing their supply. So those are two ways that we see nuclear power affecting the upcoming race, in two areas where we're really going to see both sides kind of debate over it and talk about how it's going to affect November.
Christian, if I can just follow up a little bit, let's set aside for a moment to the proliferation issue, and Detloff touched on that also, is the one issue that's being discussed, at least right now, and it's center stage in terms of the media. But let's go back to the domestic issue and domestic energy issue you brought up with respect to nuclear power versus something else. And you know, we introduced you as students for Obama, so let's assume you have some sympathies for his cause. But thinking about his strategic problem, in that public opinion shows that the environmental community that's very concerned about reducing greenhouse gas emissions, the climate change issue, is very divided over whether or not a viable alternative is going to include nuclear power, or should. So how does that fit into anything that the president can say that won't damage his reelection, or what would his position be to capture both sides at the same time?
I think Professor Detloff kind of addressed what a large part of the strategy is, and that's to kind of play to both sides. In one area where he's tried to block Yucca Mountain, our ability to put nuclear waste there, and still push nuclear power. So he's kind of tried to address the concerns of environmentalists where they think that nuclear power might hurt us in terms of waste, but at the same time try to appease the people who think nuclear power could help us in terms of energy generation.
That's a difficult one, I think, but that's all right. We'll come back to it. Travis, how about yourself?
Sure, absolutely.
And grab the mic over there a second.
Actually,
you good?
Okay, so hopefully you can hear me. Okay, so my background actually comes from the more international relations aspect of nuclear power and nuclear energy and nuclear weapons technology. And I think that an interesting comment in terms of the debate of what the United States should do in terms of nuclear technologies is with regards to the Nuclear Proliferation Treaty through the United Nations. And the understanding through that is that non-nuclear capability in terms of weapons technology states are entitled to technologies in terms of energy through nuclear power. Iran, interestingly enough, is a signatory to the NPT treaty and is therefore entitled to nuclear technologies for energy. The current debate right now is that Iran claims that their current systems are for this energy. The issue is that they are currently enriching uranium instead of using other sources, which allows them to say, oh, we're going to use this, but in fact they could also be using it for nuclear weapons, which is largely the debate and point of contention for the United States in that region. But that said, I think in terms of what the United States should do then, I think that one of the primary goals should be to spearhead the effort to lead in clean, usable, environmentally friendly technologies and ways that they can develop the nuclear energy environment so that they can export these safe best practices to other countries. Because in terms of weapons of mass destruction and the idea of mutually assured destruction, best practices and the have and have-nots debate also plays into the United States considerations.
Let me just clarify, at least for myself and maybe for others, you said the United States should lead in clean. Do you include different kinds of nuclear technology, clean, or you mean other than nuclear?
Other as well as nuclear technologies, especially with reference to the United Nations guaranteeing non-nuclear power states the right to nuclear technologies for energy.
So that's a great question, but I have to go to Professor Detloff. Yeah, Professor von Waterfeld. Detloff.
Yes, sir.
So, is there a technology out there on the horizon that might accomplish Travis's image of a less threatening in terms of proliferation and military uses, nuclear?
Well, I think the easy way to do that is to forbid completely the enrichment and reprocessing in the individual states that want to have nuclear power, and to provide the enriched uranium or the plutonium for them under international control. So this would essentially be a mechanism that would be done by the IAEA. It's the decoupling. The key thing is to decouple the enrichment and reprocessing from the states that do this. Like Germany, for example, buys enriched uranium and does not have its own enrichment facilities. So that's one part. The reprocessing, of course, is to spend fuel and then sending it back. Right now, again, very few countries do reprocessing. The United States has decided not to do reprocessing voluntarily under Carter because of the dangers of increasing the proliferation risk if you do reprocessing. Allowing any country, non-currently a nuclear weapons country, to allow any country to do reprocessing opens up this possibility. So it's really controlling the nuclear fuel cycle that does it. It's not changing the technology, it's controlling the nuclear fuel cycle. And by the way, that is also something that is not currently on the table, but I have discussed with leaders of the IAEA, the International Atomic Energy Agency, to find regional solutions to nuclear waste disposal. Because right now, according to the IAEA statutes, each country that produces nuclear waste has to bury its own nuclear waste, has to dispose of its own nuclear waste. That doesn't make a hell of a lot of sense if you look at Europe, for example, which has multiple countries that produce nuclear waste? Why should they all put it all in their own country? They could go to your friendly Russian neighbors who have offered taking the nuclear waste. But if you do that, by the way, you have to do it again under international control, because you can't put your nuclear waste to a country that then may later on misuse it.
So there is a non-energy generating strategy if you control at both ends, according to Detloff's thinking, and that's what you were imagining, Travis?
Yeah, the only comment with that type of scenario is I'm just wondering how effective the United States or the United Nations or the IAEA would be in initiating this oversight, especially when you look at the ability of countries to leave the treaty, such as with North Korea, which is now dead set on developing these technologies, and Iran, I guess, going through the current mechanism. What is stopping them from saying that our sovereignty is more important to us than this treaty, simply leaving the treaty and then entering their own way, considering that we are already doing economic sanctions and whatnot through the United Nations?
Well, that's absolutely true. I mean, my impression of the IAEA is that it's a relatively weak organization. So if you design this, you have to design it in a way that ownership actually of the reprocessing and enrichment sites is managed and physically taken with fences and everything by this international entity, which may or may not be the IAEA, but certainly there would be some involvement of the IAEA. So if, for example, make a simple case, France currently does reprocessing in Le Hague. If it does reprocessing for several countries, including Japan and Germany, the United Kingdom does reprocessing at the coast, the Middle Eastern coast, the Sellafield, and mostly for itself, also for Japan. Those facilities would have to go physically under international control. Can't leave it to the country, because then the country might just say, well, to hell with it.
Right.
We'll just use the material to build nuclear weapons.
Christian, comments? Travis?
That's fair.
I mean, if not, I'll open up to the floor for questions. Any questions to the panelists or comments on this issue? What you've heard about the problem and possible strategies. Please introduce yourself.
My name is Peter Thomas. I'm a graduate student at the Price School. I had a question pertaining to the safety of nuclear power and maybe the comparative advantage that the military has in using nuclear power in boats and ships, and whether or not it's just happenstance that they haven't seemed to have any problems. I believe the Russians have, or excuse me, the Soviets had problems in airing out a couple of their nuclear submarines, but it appears that the United States military has some type of comparative advantage that keeps their nuclear power on their ships somewhat safer than the private sector, and I was wondering if there's any correlation between that, or if it's more just happenstance.
You know, I'm not very familiar with nuclear power plants on ships, mainly submarines. My first guess, and I haven't heard any particular accidents except for the ones in Russia. My first guess would be that they're much smaller. The units are much smaller than a 1,100 megawatt unit in an electricity generating nuclear power plant. I would have to check whether they have the same meltdown risk. I kind of doubt it. I mean, the smaller they are, the more easy it is to cool them. And you're in a lot of water there, so you can probably get cooling water relatively easily.
Other questions? Well, I do, and I have told all three of the panelists, given, Detloff, your concluding comment that if the United States is going to take the reduction of greenhouse gases, that climate change threat seriously, nuclear is going to be in our future.
Right.
So you say that fairly definitively, and maybe I think it would be helpful if you'd explain a little bit further for the audience here who will be living through this process that actually hasn't been experienced since the 1970s of a proliferation of nuclear plants in the United States.
Yeah. Well, okay, so we at the International Institute for Applied Systems Analysis have been working very closely with the IPCC, the International Panel for Climate Change, the UN organization, about energy mixes in particular. What sort of energy mixes could the world sustain under various climate change scenarios. And both globally and in the United States, it turns out that there are severe limits to doing that unless you radically increase, well, first of all, you have to basically phase out fossil fuels. I mean, eventually by 2100, you have to be gotten rid of fossil fuels. Secondly, you have to ramp up tremendously renewables. And for whatever is left over, you have to make up with some other technology, either with a huge breakthrough in solar or with nuclear. Now, solar is still so behind financially that it may not be competitive. But again, if the crisis comes, if there's a real crisis in visible and tangible terms with climate change, I think the cost of solar will be okay. You know, so solar can make up for a lot too. Not everywhere, but certainly in the west of the U.S. I think there is an interesting other overlay here, and that is that all of the rapidly developing countries, the BRIC countries, Brazil, Russia, India, China, who, by the way, were all members of YASA, as well as South Africa, Korea, Malaysia, or generally Southeast Asia, their major concern is development. And if they develop as rapidly as they have in the last 10 years or so, their energy supply is going to shoot through the roof. And if they do it with coal, we're going to be doomed even more. So they really have to think hard about renewables in those countries as well as nuclear. And they like nuclear. The one thing that astonished me in discussions with the rapidly or the emerging economy leaders was they call our concern with climate and our restriction on nuclear use, on the other hand, a form of neocolonialism, which I found a very strong language for what we're doing. I mean, essentially the United States, some of us are concerned about climate change, so I think that we do, some of us do favor, and because of that, a smart and safe development of nuclear power. And I do think that the leaders in the Obama administration, certainly Stephen Chu, who's the head of the Secretary of Energy, and John Holdren, who is a science advisor, are cautiously optimistic about nuclear power. Yes?
I have a question.
Your name?
Sorry, my name is Louis Macero. Nice to meet you all. Thanks for coming. I had a question about the idea of deep geologic repositories. I know that there are sites that are ideally suited to house these kind of waste, but and if there was somewhere that we found within the United States that was perfect to maybe contain all of them, I'm just wondering how do the risks associated with transporting the waste, how does that factor into it, and why was Nevada shortlisted?
Well, okay, so when we looked at the 5 sites that I showed up, there were 3 of them were salt mines, and salt mines are generally pretty good. Yucca is a tough mine and pretty stable, very little water. And Hanford was the most risky site in many ways. So Hanford was out. The 3 salt mines are probably still or now again under consideration. Yucca was considered best for a number of reasons. And so once you have the other thing you notice, and this comes to your transportation issue, is that if you compare where Yucca is located to where all the waste is located, it's kind of strange, right? It's like you have to travel all across most of the waste is in the east. So there's a lot of transportation involved. Of course, the trade-off here is if you go further to the east, the more you get into rainy zones and areas with less stability and more precipitation and potential for corrosion. So let's assume that Yucca or some site like that is chosen eventually. There has been a very significant study by the National Academy of Sciences that I was a committee member on the safe transportation of nuclear waste. The study came to the conclusion that there are, in normal operating conditions and normal accidents like fires, train accidents and things like that, technically there are the risks are very, very low. The remaining risks are terrorist attacks on nuclear waste transports and very extreme accidents that could occur. my own conclusion of it was that compared to the other risks that we have, like leaving the material spread all over the country and making them sort of potential targets, the transport is probably the lesser of the two evils.
Another question over here?
I'm kind of interested of what do you think the future of the nuclear plant cooperation between US and China? I know right now Westinghouse is helping China to develop a nuclear power plant in China. I'm curious to see what do you think the future? Will they have more cooperation in this kind of field?
China is quite aggressive in developing nuclear power plants, and of course when you look at their actual plants, I think they're building a coal plant a week or something like that.
60 a year.
And I'm sure you've been in Beijing and Shanghai recently. It's not a, you know, pollution-wise, it's not a pretty picture because of that. But also, I think there is a tendency to try to leapfrog into these new technologies. And China is having a very ambitious plan to build nuclear power plants. I think they have their own construction capability, so they don't have to rely on the U.S. with Westinghouse. General Electric and Westinghouse are the big construction firms that build nuclear power plants. They don't have to rely on those anymore. So I would say China is pretty self-sufficient with nuclear power.
Actually, currently, right now, as for nuclear plant in China, most of them they want to bring in technology from U.S., France, or other countries. China just has one nuclear plant, which is fully supported by our own technology.
Yeah.
And the others, they are supported by technology in other countries.
Yeah. Well, I mean, I think there's always an exchange of the new technologies. I mean, the one thing that I'm watching very carefully are the new small passive safety designs. So you build a nuclear power plant with a passive safety system where if it melts down, it actually cools off by itself without interference of any operator or of any person. Those are the kind of things I think that China will also be looking at in the future. So there will be technology sharing. I think Westinghouse and the French constructors and the British constructors are still leading. So is General Electric. So there will be exchange. But I think China essentially wants to build their own.
I saw a hand up here.
I had a question directed towards Travis, since he's part of the IRA. Going back to that last presentation, he said that, increasing our nuclear power capabilities and nuclear technology, it would result in a decreased dependence on oil and gas in the future. How would this affect the U.S.'s relations with, or the developed world's relations with countries in the Middle East, particularly the Gulf countries, in the long term?
I think that the United States is aiming towards less dependency on oil as it is, regardless of nuclear technology considerations. And the countries in the Middle East are aware of that. That said, oil is the #1 exporter of the region, and they have a huge interest in the United States' investment and role in that field. But I think as the United States, again going back to the NPT treaty and allowing these states to also invest in nuclear technologies based upon energy, I think the United States' investment in nuclear technologies for energy will benefit both regions in terms of allowing them to advance in their technologies as well. In terms of the economic side, unfortunately I'm not a business major, so I can't talk about exactly the number aspect of it, but it's a tough question.
Would this give, so with the Gulf countries specifically, not the entire Middle East, would they have less leverage over the whole U.S.-Israel-Palestine issue? Because I know that's sort of an implicit factor in how the U.S. conducts its foreign policy.
I wouldn't think so, no, actually. I would argue that the United States' relationship with Israel is firmly founded in many other aspects other than geopolitical considerations of the region. Not to say that those are not a huge factor in our relationship with Israel, but I think that it will force them to approach the relationship differently. And it also challenged the United States to approach the relationship with those countries differently. And developing more sustainable nuclear technologies in terms of energy.
Let me just make one more general comment, and that is the United States, on a per capita basis, consumes about twice the energy that any other industrialized country consumes per capita. And that would include Japan and Germany and France and so on. And in terms of CO2 production, about 10 times as much as the average individual in the world. The best thing we can do is not so much relying on nuclear power or other technologies, but at the moment, in the most effective and the best way of reducing greenhouse gas emissions and energy is by reducing energy consumption. And you do that in two ways. There are certainly plenty of opportunities for conservation, but even more so, there are plenty of opportunities for energy efficiency. Anybody who looks around in their houses and who has spent some time in Japan or in Europe will find that the energy efficiency measures in America, in the United States, are laughable. I don't know if you have been to a hotel anywhere in Europe where, in order to turn the lights on, you have to take your hotel key and put it into a slot. And when you leave, you take the hotel key and everything goes off.
Yeah.
That's a very simple thing. I never understood. You don't never see that in the U.S. and many other things. So that space heating is very inefficient and so on and so forth. So I think that on that big picture scale, the technologies are probably a secondary layer of improving the climate change situation. The first layer in the United States is conservation and energy efficiency.
You've raised a number of points in the comments here, but I want to go back to the issue of the election and then what we're going to do as a society, if I may. And one on the election is that these alternatives probably aren't going to be on the table. That is, the long-term strategies for addressing a safer nuclear power strategy or nuclear power at all, partly because, as Detloff said, no one's going to oppose or bring it up because they don't disagree that much, except for the issue of the relationship between energy and the environment, and energy and coal issues and pipelines and so forth. So I'm curious, if I may indulge upon you, how many of you think that the issue of climate change and greenhouse gas emissions as a source of that is something of significance to your future? And the rest of you don't take it as a problem. For those of you who do, how many would favor letting California, by the way, establish additional nuclear plants in our state? And the reason I mention that is because the studies I've seen argue that California can accomplish its 2020 climate change strategy, greenhouse gas reductions, through all the conventional means and alternatives that are being discussed today. And we have no way of getting to 2050, which is actually our stated goal, which is what the International Panel on Climate Change suggests, the 2 degrees Celsius that we need to reach in our state today. So I think you've posed, Detloff has, a real challenge not only for the nation, but for our state with our extremely allegedly progressive climate change strategy and no way to get there in terms of the consumption patterns of Californians. So if conservation could get us there, Detloff, I would be delighted, but I've known no analysis that suggests that's realistic.
Well, actually, California is the one state that does quite well in energy efficiency.
I know, but if you take
because of the weather,
well, we do have weather strategies for dealing with conservation throughout the state. And we are a lead in the nation that way. But I'm just saying that we don't have a strategy in California to get to our 2050 goal. And so nuclear is not going to go away for us either. And I saw a few hands that were in favor, but I'll bet you if I asked how close to you, I would get the answer we normally get, which is we may need it, but not close to me. And that's real. That's happening all throughout our country. So this will be interesting. Well, let me thank our panelists. I see our time is up. Christian, Travis, Detloff, thank you for sharing this with us and probably alerting us that it's not going to be an issue in the 2012 election, but it's going to be with us very seriously. Thank you very much. Have a good day.